Kia ora Year 12 and Year 11. In this video we're going to practice how we find the equation of a line when we know the gradient in one point. So in class last week we spent quite a while figuring out this formula for ourselves. In this video I'm just going to recap that quickly and then get into using the formula that we developed. I tried doing a video going right through how we did it in class, and I found it was just getting too long. So if you were away for that lesson, come and talk to me and I'll show you individually what we did. Okay, so we've got a point that we're going to call x1, y1. And we also know the gradient m. So m is going to be a number. So for a point to be on that same line, we can put the point here. And we're going to call that point xy. Now we know that that point xy is going to have gradient of m. Okay, because all of the points on that line have got that slope, so m might be 2. And we know that m, the slope, is equal to rise over run. So the vertical change here is y minus y1, and the horizontal change is x minus x1. So here's what we get. Now if we cross multiply, we're going to get m times x minus x1 is equal to y minus y1. We usually write it the other way around, but it doesn't really matter. So this is what we call the point gradient formula for getting the equation of a line. And this is massively useful in coordinate geometry. So it's one of those things that you need to learn so that you're really comfortable with using it. In this video we're going to do 4 little examples that use this rule to write the equation of the line. And we're going to end up with a line that for now is going to be in this form, y equals mx plus c. Okay, so on to the first example. Alright, find the equation through the point 3, 2 with gradient of 4. So we're going to quickly sketch that on this very rough graph. I haven't even put axes on, so we're going to go out 3 and up 2. That gives me the point, and I want the gradient to be 4. So that's going to be out 1 and up 4. 1, 2, 3, 4. So it'll be about there. So we can see that the line is going to go something like this. Whoosh. That's meant to be a straight line, right? So let's put that into our formula. Well, y minus 2, right, that's the y1, is equal to m, 4, times x minus 3. That's all there is to it. Now we just do a little bit of algebra. So y minus 2 is equal to 4x minus 12, and we rearrange that to make y the subject. And we get y equals 4x minus 12 plus 2, so 4x minus 10. Now if you look at my very dodgy graph, you can see that it's not quite right because I'm trying to scoot through this to make it fast, but my intercept is down here, so that value is at negative 10. On to the next example. Alright, same idea. Find the equation that's going through negative 5 and negative 2 with the gradient of 1/2. So let's put on that point, negative 5, back 1, 2, 3, 4, 5, and down 2. So there's my point. This time the gradient's going to be 1/2. So that means out 2, up 1, out 2, up 1, out 2, up 1. So if we do that nicely, and this time I will use a ruler, do this properly, and join the dots, we can see what my answer is going to be. But let's do it using the formula. Just have to get this line straight. I'm not sure if you can see that wiggling around while you're watching the ruler, but there we go. So here's my line here. Okay, so y minus y1 equals m times x minus x1. Whenever you use this rule, start off by writing down the formula. It will make your substitution way easier and it will minimize your mistakes. Right, so we're going to have y minus negative 2 equals 1/2 times x minus negative 5. Y plus 2 is equal to, let's change to the black pen, 1/2 x plus 5 over 2. Now I just need to subtract 2 from both sides. So y equals 1/2 x plus, well, 5 over 2 minus 4 over 2 gives me 1/2. So that's my equation of the line. Now let's get rid of that ruler so that we can see it. And that looks exactly right. Okay, so let's just write that in a bit better. So y is 1/2 x plus 1/2. So there's my intercept here at 1/2. Next example is a little bit different. I want you to try it first without using this rule and see if you can get it. Okay, find the equation of the line through -6, 4 with slope 0. So what does slope 0 mean? Well, a line with slope 0 is just a horizontal line. So let's put on my point and then do it without even using the formula. -6, 1, 2, 3, 4, 5, 6, and up 4. There we are, there's my point. So the line through that point with slope 0 is going to look like this. There's my point, and here comes the line. Whoosh. Now that's meant to be exactly horizontal, but it's pretty close. So we know that the equation of a horizontal line is written as y equals k. In this case, y equals 4. Let's look at whether we would have got there if we'd used my point gradient formula. Now, happily, the answer is yes, we would have. So y minus y1 is equal to m times x minus x1. And we get y minus 4 is equal to 0 times x minus -6. Y minus 4 equals 0, because 0 times this factor is just 0. And so my equation, doing it that way, is y equals 4. Okay, so it does work in cases of horizontal lines. Have a think about what would happen if I'd said a vertical line through that point. Just think about what you'd do there. Right, one last one, and I've stepped it up a little bit, so you're going to have to do some extra calculations for it. All right, this time we're finding the equation of the line with slope 2, so far so ordinary, that goes through the midpoint of these 2 points. So as we move further through this topic, we're going to link up more and more of the early skills that we did. So what's the midpoint? Well, the midpoint is halfway between the x values, so 1 minus 3 over 2 and 5 minus 1 over 2. So the midpoint here is -1 and 4 over 2 is 2. So this is the point that I'm using in my point gradient equation. So there's my formula. So I'm working with this, and I've got m equals 2. So 2 bits of information that I have to have, the gradient and the point. And then all we have to do is substitute. So we get y minus 2 is equal to 2 times x minus -1. Let me change the pen colour again. I wouldn't mind you letting me know if you can see that blue okay on the screen or not. If you can, I'll keep on using it. So we get y minus 2 is equal to 2x plus 2, which gives me as a final answer, I'll just put it up here, y equals 2x plus 4. Now, I haven't drawn the graph for that one because I don't want this video getting too long, but if you're doing this question in your book, I'd like you to quickly sketch the graph of everything that you've done. So you should have on your graph the 2 points, and then the midpoint, and lastly the line that goes through the midpoint. Thanks for watching. There are lots of good examples of this in theta. I think it's exercise 106 or 107, but I'll let you know in class.